Hello people, this is our standard Unit 8B review video. I hope that's what you were trying to find. So this standard is about molarity, which is a type of concentration, and then we will all be connecting it to stoichiometry, which we've seen a lot actually, but mostly we saw it in Unit 6A, and there really was only one standard in Unit 6. Alright, so some people liked that, some people did not like that unit. So, molarity. Formula for molarity, we have the concentration molarity is equal to the moles, which we use N to represent moles, over the volume, and volume must be in liters, and this is of the entire solution, so in liters of solution. Alright, so just conceptually, let's make sure we understand concentration before we actually do any calculations. Concentration is just a ratio of solute to solvent. It's basically how compact the solute is. So for example, if we take, let's say the background, the purple background here is my solvent, and we put in 6 solutes here. Now that's kind of homogeneous, they're spread evenly enough. Okay, and if I did something like I decreased the volume, okay, let's say I boil off some water or something like that, but I leave the same number of solute the same. Alright, well now it's more compact. This is more concentrated. If I somehow got rid of some solute, now it's much less concentrated because the ratio of solute to solvent is lower. If I add more solute, it gets more concentrated. I could add even more, make it really concentrated. Right? If I increase the volume, so maybe I add more water, it's less concentrated. So now the solute is able to spread around more often. Alright, so there's lots of ways you can manipulate the concentration by changing the volume or by changing how many actual solute particles are inside of your container. Now, I should make it clear, if you just pour off half of your solution, like let's say you just pour off the top half, you're not actually changing the concentration. Assuming it was homogeneous to begin with, which I don't know if mine really shows that it is, it's still just as concentrated here, because although you're getting rid of solute, you're also getting rid of solvent. Or you can say it the other way. Although you're getting rid of the purple solvent when you pour this off, this top part, you're also getting rid of these solute particles, and so the ratio stays the same. Alright, so that's concentration, is a ratio. So you can see how if we look at our molarity calculation, we have a ratio of moles over volume. So it's a ratio of solute to the solution volume. Right, so to solvent or solution, if I expand my concentration. There are other measures of concentration, but this is the one we're using. Alright, so let's do some practice problems. Number 1 here. What is the molarity of a salt solution with 29 grams of salt in 300 milliliters of solution? So first thing, let's remember our formula. We have molarity equals moles over volume. If I read this, it's asking for molarity. So make sure you always annotate that's big M. It says salt, so I'm assuming table salt, that's NaCl. With 29 grams, this is the mass in 300 milliliters, that's the volume. Okay, I know my formula, I'm going to write it again, is molarity equals N over V. It's looking for M, so that means I need N and V. I have V right here, but I don't have N, I don't have moles. But I do have the mass, so I can actually take the mass and convert that to moles. So I put moles on top, grams on the bottom. So now I'm going to use my periodic table to find the molar mass. So the mass of sodium plus the mass of chlorine. Sodium is 23, chlorine is 35. This is from the periodic table. We add that together, we get 58 grams per mole. So that means in 1 mole, there are 58 grams. So grams cancels out, you do your math, you get 0.5 moles of NaCl. So this is NaCl. And that's equal to N. Okay, so now I can plug it in, but no, I can't, because remember, V has to be in liters, not milliliters. So now I take my 300 milliliters, and I'm going to convert this to liters. So I have to divide by milliliters. There is 1 liter in 1,000 milliliters. Milliliters cancels. You get 0.3 liters, and this is equal to V. So now, molarity equals N over V. So we put in 0.5 moles NaCl over 0.3 liters. Alright, and so if you do your calculator here, we get 0.5 divided by 0.3 gives us 1.6 repeating. Alright, so 1.6 repeating molarity. Technically of NaCl, if I'm specific there. So there we go. So if you're finding molarity, you just need to find moles and volume. Sometimes you got to convert before you do that though, because it's always got to be in liters. Volume has to be in liters, and then moles obviously has to be in moles. Let's do one more practice one. It says if 0.5 liters of a 5 molar solution of aluminum sulfate is reacted with calcium nitrate as shown below, how many grams of calcium sulfate will be produced? Well, first off, let's make sure we know which one's which. This one is aluminum sulfate because it's aluminum and sulfate. That's sulfate. Calcium nitrate is right here, so that's this guy, calcium nitrate. And then it's asking us how many grams of calcium sulfate will be produced. Alright, we're starting with 0.5 liters, that's a volume. We're giving 5 molar, that is a molarity. Now this is for aluminum sulfate, and we're trying to go to grams. So I can use this to find my moles here, my N, right? And then I can use this equation to find my moles of calcium sulfate and then my grams. So basically, we're going to go from molarity slash volume of one chemical to moles of that chemical to moles of another chemical to mass of that final chemical. Okay, so first thing I do is I take my equation, molarity equals N over V. I'm going to plug in my 5 molarity equals N over my volume, which is 0.5 liters. I'm going to get N by itself by multiplying by 0.5 liters. So that cancels. Alright, and that's going to give you N equals 2.5 moles. And this is, it's a solution of aluminum sulfate. So this is Al2SO4 3. Alright, I'll switch colors. So now we're going to go mole A to mole B. This is like we did in Unit 6. Actually, the rest is all Unit 6. It was just that first step that was Unit 8. Alright, I'm going to convert. So I want to cancel out moles of Al2SO4. Yes, it's a lot to write. And yes, you can do it. And I'm going to get moles of calcium sulfate. So I'm going to do moles of calcium SO4. I use my mole ratio for my equation, so here we have 3 moles of calcium sulfate for every 1 mole of aluminum sulfate. So that gives me 7.5 moles of calcium sulfate produced. I'll switch colors again. How about orange? Alright, you know my school colors were orange and blue. Gross, right? Alright, why'd I write a 2? That's not a 2. I want to write a 7.5 moles of calcium sulfate. And now we're going to go to grams of calcium sulfate, because that's what it's asking, over moles of calcium sulfate. For this, I need the molar mass. Calcium from the periodic table is 40, plus sulfur is 32, plus 4 oxygens, and each oxygen is 16. So we add all that up, get 40 plus 32 plus 4 times 16 is 64, gives us 136. hope I did 4 times 16 right. 4 times 10 is 40, plus 4 times 6 is 24. Yeah, 64. Okay, so that's 136 grams for every 1 mole. Mole cancels out. So we get 7.5 times 136 gives us 1,020. Whew, that's a lot. All right, so basically a kilogram of calcium sulfate would be produced just from half a liter of 5 molar solution. Wow, that's some heavy stuff, man. Okay, so you should understand the idea of concentration. You should be able to do relatively simple ones like this, and you should be able to do ones that incorporate stoichiometry and equations like this. Kind of like the crime scene lab that we're going to do or did do, depending on when you're watching this. All right. Sign up for a tutor, come to office hours, check your notes if you need help. There's lots of resources that you have available to you. Bye-bye.